Hi everyone, today we're going to do single replacement reactions using the activity series. Yay! Look, there's a heart. Here's the actual definition of single replacement reactions, which you've already seen many times. A single replacement reaction occurs when one element, an element is the big word, replaces another in a compound. The element is the one that goes to the party by himself. The compound is somebody that is hooked up, if you will, and that element's going to come in and break them up. The things that actually do the breaking up, a metal can replace another metal, the positive ions trade, or a non-metal can replace another non-metal when the negative ions trade. Either way, it's going to follow the same pattern. So let's check one out. So here is our first equation. Remember that Google Drive doesn't work too good with this, and all of these squares are really arrows, okay? So we have this beautiful arrow, okay? So this is saying zinc plus hydrogen, HCl, does it happen, okay? So what we do is we use the activity series and we look for zinc. So here's zinc, okay? Zinc is going to replace hydrogen because they're both positive charges, okay? The metal, even though hydrogen's not a metal, they're both positive charges. Now, is zinc higher, we have zinc here, than hydrogen on the activity series? Absolutely. So because of that, this reaction will happen. Now before I write anything up at the top, I'm going to talk about zinc. Zinc is +2, and it's going to end up with chlorine, and Cl is -1. So we have to crisscross to get ZnCl2. Okay, so we're going to write ZnCl2 right here. And then what's left over? Well, hydrogen has to be by himself, so we're going to write H. But we just don't write H because of Hunkelbrief, so we're going to write H2. So there is our formula. Thing is, not balanced. I have 2 hydrogens, and I have 2 chlorines, and over here I just have 1 and 1. So I'm going to put a 2 right there. All right, let's try another. So now we have sodium bromide plus Cl2. Well, sodium has a charge of +1, bromine is -1, chlorine, if it was making a charge, would be -1. So what chlorine is going to do, because it's by itself, chlorine is going to replace bromine, okay? That's what would happen, but we have to check the activity series first. So we look up chlorine. Here's chlorine. Is it higher up than bromine? Absolutely. So that means this reaction occurs. So now let's take a look. So what that means is Na isn't going to be with Br anymore, Na +1, Cl -1, crisscross, or you don't even have to, it's NaCl. Okay, so I write that there, NaCl, plus, what is left over now? Bromine. And it's Br, but it's Hunkelbrief, so we put Br2. Is this equation balanced? I have 2 Brs on the product side, but over here on the reactant side I only have 1, so I need to put a 2. So I'm going to put a 2 here, even though it's hard to see. And because now I have 2 Na, I put a 2 here, and that is all balanced. Awesome. Here we go again. Now we have aluminum plus copper nitrate. Aluminum is by itself, and aluminum is a metal, copper is a metal, so aluminum's goal would be to replace copper. Let's see if it really happens. So we look on the activity series, and here's aluminum. And then we look on the activity series, and here's copper. Aluminum is higher up, so that means this will happen. Okay? However, let's think about the charges. Aluminum would be +3. Copper, in this case, is +2. Nitrate is always -1. So if aluminum is going to hook up with nitrate, let's take and look at what's going on with the charges. Al +3. And NO3, and I'll put it all in parentheses so you know it stays together, is -1. We have to crisscross. Makes you jump. So Al, parentheses, NO3, close parentheses, 3. That'll go right up here. Al, NO3, 3, plus what's left over? Oh, Cu. So I put the Cu right there. Is it balanced? Absolutely not. Time to balance the reaction. So if I look here at nitrate, like you can see here, there are 3 nitrate groups, and over on the other side there are 2. Usually when that happens, we have to make them both 6. So I'm going to do that by putting a 2 here in front of aluminum, and I'm going to put a 3 here in front of copper. So now I have 6 nitrates on each side. But now I just have to fix up my copper, put a 3 here, and I have to fix up my aluminum, put a 2 here. All right, now we're balanced. All right, so that is the 4th example. Let's do another one. All right, now it looks very similar except for it's backwards. Now it's copper plus aluminum nitrate. Well, copper would replace the other metal, okay? Copper is usually about +2, aluminum's +3, nitrate's still -1. Will that happen? So we got to go to the activity series and find copper. Here's copper, okay? Beautiful, copper's amazing. And here's aluminum up here. Since copper is not above aluminum, this does not happen. We call this no reaction, and we just put a NR, okay? Remember, NR stands for no reaction, okay? All you have to do is use the activity series. Let's try it again. All right, magnesium plus hydrochloric acid. Remember, magnesium is +2 based on your periodic table. This is +1. This is -1 based on the periodic table. So our positives are going to exchange. So magnesium would replace hydrogen. Let's look at the activity series. Here's magnesium. It's way higher than hydrogen. So guess what? This reaction happens. Awesome. So that means magnesium, which is Mg +2, okay, is going to get with a Cl, which is -1. And those don't cancel out, so we have to crisscross. MgCl2. All right, so we put an arrow, MgCl2. And what's left over? Hydrogen. Is it just H? No, it's H2. Awesome. Now, is that a balanced reaction? No. I'm going to put a 2 right here. There we go. Ready for more? Oh yeah, because I have 14 million slides of this. Let's keep going. All right. Lithium plus hydrogen, water. And remember, water is just HOH, okay? So because of that, lithium is +1, hydrogen is +1, hydroxide is -1. So lithium is going to replace hydrogen. So let's look up lithium. Lithium's way up at the top. Guess what? No matter what, it's going to go. Lithium's going to balance. So this ends up taking the place of the hydrogen, and it means lithium, Li +1, is going to end up with OH -1. Those cancel out, so it's LiOH, lithium hydroxide, plus hydrogen's left over. However, do I just leave it as H? Nope, H2, Hunkelbrief. Now it's time to balance these bad boys. And actually, it's kind of already balanced for you because the 2's are already on there. Awesome. I think we just have to put a 2 right here. Good. All right, here we go again. Calcium plus HOH. All right, here's calcium on the activity series, way higher than hydrogen. So calcium's going to replace hydrogen. So let's think about the charges. Calcium's +2. Hydrogen is +1, hydroxide's -1. So calcium is going to end up with hydroxide. Okay, and I like to think of hydroxide in parentheses. We got a crisscross here, and this becomes Ca parentheses OH2. All right, so we have that CaOH2 plus whatever's left over, hydrogen, which is H2. We need to make sure that there's that many hydrogens and that many hydroxides, so we put a 2 there, and now it is all balanced. Beautiful. We're almost done. Magnesium plus copper chloride. Does this reaction happen? First, here's magnesium on the activity series, and here's copper. So guess what? It's totally going to happen. Mg is +2, copper's +2, chlorine's -1. So Mg will replace copper, and when that happens, this forms MgCl2 plus Cu. All right, I'm going to leave the rest of these guys for you, okay? But the main idea is that you should be able to go through a whole bunch of single replacement reactions. You always check the activity series, and then you simply replace the one compound or the one element with the other element that has the same charge. Hope this was helpful. Thanks!